A converging lens of focal length 12 centimeter. Here it is our converging lens of focal length 12 centimeter. F is 12 centimeter and diverging mirror of focal length 7.5 centimeter are placed 5 centimeter apart. Here it is our diverging mirror whose polished surface is on this side. So for this diverging mirror, 7.5 centimeter is the focal length. So focal length for this diverging mirror is 7.5 centimeter. That means its radius of curvature is what? 15 centimeter. Double of the focal length. So radius of curvature is going to be the 15 centimeter. So converging lens of focal length 12 centimeter and diverging mirror of focal length 7.5 centimeter are placed 5 centimeter apart. Distance between the two is given to be 5 centimeter. And their principal axis coincide as shown here in this diagram. So where should an object be placed so that its image coincide with itself? So we need image of the object at the location of the object itself. So that can happen only if the light ray is reflected back along the original path. So when a mirror can reflect back the light ray to its original path when it is incident normal to it. And here it is diverging mirror, and suppose this is the center of curvature of this diverging mirror. Okay, if we draw a line from center of curvature anywhere, this line is going to be the normal. And suppose from this point there is a light ray coming this way, and after emerging from the lens, it follows this path. Okay, in absence of this mirror, the image of this object would have been the point C according to this converging lens. But if this point is happen to be the center of curvature of this mirror, then this particular line will be normal to the surface of the mirror. That means this particular diverging mirror will reflect back this light ray to its original path, and the image, of course, the real image will be formed at the location of the object. So here you can see that everything is now decided. We have to find the value of the u, this distance, that where should an object be placed. So for lens formula, we have 1 by f is equal to 1 upon v minus 1 upon u. So what is the focal length of our converging lens? 12 centimeter. And in case of convex lens, we give sign positive. So it is 1 divided by plus 12 is equal to 1 upon v minus 1 upon u. U is something that we need to calculate. So it is unknown, so let it be like that only. And what about V? So according to this lens, this image should form at the center of curvature of this diverging mirror, and center of curvature of the diverging mirror is basically 15 centimeter behind this diverging mirror, because focal length is given to be 7.5 centimeter. That means this is 15 centimeter and this is 5, so total 20 centimeter. So in case lens forms a real image at a distance 20 centimeter from itself, then it will solve the purpose, because the light ray will fall normal to the diverging mirror and will be reflected back to its original path. So V for this lens has to be plus 20. So now on solving this particular equation, what we get, the value of u is 1 upon u is equal to 1 by 20 minus 1 by 12. So it is 12 minus 20 upon 240. That means it is minus 1 divided by 30. So the value of u is minus 30 centimeter. That means 30 centimeter from the lens. So here this distance must be 30 centimeter, and if it is the case, then its own image will be found on its location itself. So option A will be the correct option to this question.